We need to talk about something that's happening right now. Something that has astronomers breaking protocol and NASA quietly repositioning billion-dollar spacecraft. And I'm going to be direct with you. What I'm about to show you doesn't just challenge our understanding of how the universe works, it shatters it completely. On January 7th, 2026, the Hubble Space Telescope captured images that should not exist. These aren't blurry photographs open to interpretation. We're looking at the highest resolution composite ever constructed of an interstellar visitor, and buried in that data is something that violates the fundamental laws of physics as we understand them. The object is called 3I/Atlas, and it's not behaving like anything we've ever seen before. Look at this image closely. See that sharp, coherent structure? That brilliant jet of material extending from the nucleus? Now look at which direction it's pointing. It's aimed directly at the sun, not angled toward it, not vaguely in that direction, directly at it, like a weapon being aimed at a target. And here's what makes this impossible. Every force in our solar system should be pushing that material away from the sun, not toward it. Let me explain why this breaks physics. For centuries, we've understood comets as dirty snowballs, mixtures of ice and rock that heat up as they approach the inner solar system. As they warm, they release gas and dust through a process called outgassing. This creates those beautiful tails we associate with comets. But those tails obey absolute rules, rules dictated by two unstoppable forces: solar radiation pressure, the literal pressure of sunlight itself, pushing particles away from our star, and the solar wind, a hurricane of charged particles screaming outward at hundreds of kilometers per second. Both forces work in the same direction. They push everything away from the sun. This isn't a tendency, it's not a suggestion. It's a fundamental law that has held true for every single comet we've ever observed. Until now. 3I/Atlas is fighting upstream against forces that should be tearing it apart. The material in this jet is traveling toward the sun, maintaining perfect cohesion across a distance of 400,000 kilometers. Let me put that in perspective. The distance from Earth to the Moon is 384,000 kilometers. That's the farthest humans have ever traveled. The Apollo astronauts needed 3 days to cross that gap. This jet of material is longer than that entire distance, and unlike a cloud of gas that should disperse within hours, it's holding together with structural integrity that defies explanation. When hints of this feature first appeared in July 2025, there was hope among researchers that it might be a viewing angle trick, an optical illusion caused by our perspective. Maybe the jet was actually pointing elsewhere and only appeared sunward because of how we were looking at it. That hope is dead. Multiple observations from different angles over 7 months confirm this jet is genuinely oriented toward the sun. The parallax analysis rules out any projection effects. There's no camera trick here. The feature is real, and it's aimed exactly where it appears to be aimed. Using advanced imaging techniques designed to reveal subtle contrast in cometary structures, astronomers discover this sunward feature is actually the dominant component of a three-jet system. While the other two jets are faint and diffuse, this sunward spike is tightly collimated, maintaining focus like a laser beam rather than spreading out like a spray. Think about what that requires. To keep a structure that narrow, that focused, while plunging toward the sun against overwhelming opposing forces, demands specific conditions. The material must be moving at extraordinary velocity, with a density we've never observed in natural evaporation processes. The physics simply doesn't work otherwise. This means we can throw out what scientists politely call the passive comet hypothesis. A passive body, one simply reacting to its environment without internal mechanisms, doesn't produce features like this. If this were normal sublimation, ice transforming to gas as it heats, the gas would expand in all directions before being swept backward by the solar wind. That's basic thermodynamics. Gas expands. It doesn't focus itself into a beam spanning hundreds of thousands of kilometers. What we're observing suggests a nozzle, a constrained release of energy that somehow remains immune to the environmental pressures that govern everything else in the inner solar system. The brightness creates another puzzle. At this distance from the sun, the feature is inexplicably luminous.
The solar wind should be stripping away smaller, brighter particles first, leaving only heavy, dark grains producing a faint, barely visible tail. Instead, the jet remains brilliant and razor-sharp. Either the particles are incredibly massive, heavy enough to resist radiation pressure entirely, or they're being replenished at a rate that's frankly impossible for an object this size. Neither explanation fits our models. And here's what should terrify you about this. The jet was already visible in July 2025. This isn't a momentary outburst from a surface fracture. This isn't a temporary event triggered by thermal stress. This phenomenon has persisted for 7 months, maintaining a precise orientation relative to the sun despite the object's movement through millions of kilometers of space. The sun isn't stationary from the object's perspective. As 3I-Atlas travels its trajectory, the direction to the sun constantly changes. Yet this jet tracks that changing direction perfectly, like a turret locked onto a moving target. In any natural scenario, a rotating nucleus would spray material in a spiral pattern. Imagine a garden sprinkler rotating while shooting water. The water forms a spiral as the sprinkler turns. That's what rotating objects do. To maintain a straight jet consistently pointing at the sun from a rotating body requires something extraordinary. The source must be locked to what astronomers call the subsolar point, the spot where the sun appears directly overhead. As the object rotates, that point moves across the surface. For the jet to stay sun-aimed, either the object isn't rotating, which brightness variations prove false, or its rotation has a very specific, very precise relationship with its orbital geometry. This is where statistical coincidences stop looking accidental and start looking like deliberate design. By tracking the subtle wobble of that sunward jet over recent months, astronomers reconstructed the spin axis of the nucleus. Every spinning object has an axis, an imaginary line around which rotation occurs, pointing in some direction in space. For most objects drifting through the cosmos, that direction is random. The chaotic history of collisions and gravitational interactions leaves spin axes pointing in arbitrary directions. 3I/Atlas is different. Its rotation axis is aligned with the sun to within approximately 7 degrees. This is an extraordinarily unlikely configuration. When an object enters our solar system from interstellar space, it brings whatever spin it had in the void. The sun's gravitational influence is far too weak at these distances to alter rotation during the brief passage through. Whatever orientation 3I/Atlas has now is the orientation it arrived with. The probability of a randomly oriented object happening to have its pole pointed almost directly at our sun is vanishingly small. But the improbability compounds catastrophically. Not only is the pole pointing at the sun, but the object's trajectory, its path through our solar system, is closely aligned with the ecliptic plane. That's the flat disk where Earth and the major planets orbit, where most of the solar system's mass and activity concentrates. Interstellar objects can arrive from any direction. The first confirmed visitor, 1I/Oumuamua, came in at a steep angle. The second, 2I/Borisov, dropped from well above the plane. They cut through like needles through fabric, crossing the ecliptic and continuing on. 3I/Atlas is different. It's sliding in almost perfectly flat, moving within the same traffic lane as the planets themselves. When you combine these factors, a rotation pole pointing at the sun and an orbit aligned with a planetary plane, the probability becomes absurd. The combined geometry is improbable at better than 1 in 10,000. In probability theory, when you encounter a 1 in 10,000 event, you face 2 options. Option 1, we won the cosmic lottery. Improbable things happen. Someone eventually beats impossible odds. Maybe we're observing the rare exception. Option 2, the underlying assumption of randomness is incorrect. If the alignment isn't random, it implies a constraint. It implies the object's orientation is coupled to its trajectory, or perhaps to the sun itself. This second interpretation contradicts everything we understood about interstellar debris. Debris is supposed to be chaotic, random. A tumbleweed blowing through cosmic wind doesn't orient itself aerodynamically unless it has stabilizing structure. 3I/Atlas behaves as if it has such structure, as if it has a purpose.
The specific alignment creates a peculiar thermal situation. One hemisphere exists in permanent daylight, the other in permanent darkness, a perpetual summer solstice that never ends, with maximum heating concentrated continuously on one pole. If this were a natural comet, that constant heating might explain steady outgassing from one location. But remember, the jet isn't a diffuse cloud. It's stable, narrow, focused. If the pole points at the sun and the jet emanates from the pole, then geometrically the jet acts like a thruster firing along the object's line of motion relative to the sun. The stability of this configuration is remarkable. If the object is elongated, as brightness variations suggest, outgassing should produce torques causing the spin to accelerate or drift over time. This is called the YORP effect, and it affects virtually every small body releasing gas asymmetrically. Yet 3I/Atlas maintains its sunward orientation. It keeps its nozzle fixed on our star. At what point does a series of statistical improbabilities stop being coincidence and become evidence? We have a jet defying physics. We have geometry defying probability. Where's the threshold where natural explanations become less credible than alternatives we're afraid to voice? The precision becomes even more significant when we examine where 3I/Atlas is heading. It's not simply passing through and exiting into the void. It's on an intercept course with Jupiter, and the timing of its arrival is practically synchronized with optimal observation conditions. The alignment with the ecliptic makes a close planetary encounter far more likely than if it had arrived at a steep angle. Objects diving through the plane quickly have limited interaction opportunity. Objects traveling along the plane have maximum exposure. The calculations reveal an encounter remarkable in its precision. 3I/Atlas will graze Jupiter's Hill sphere, the boundary where the giant planet's gravity begins dominating over the sun's influence. This boundary extends approximately 53.5 million kilometers from Jupiter. The object will pass at approximately 53.6 million kilometers. The margin is 100,000 kilometers. In cosmic terms, that's threading a needle. This brings us to the hypothesis circulating in astrophysics circles, whispered in conference hallways but rarely stated openly. Among Jupiter's many moons is a tiny irregular satellite called Upori, only about 2 kilometers across, orbiting retrograde in a region populated by captured asteroids known as the Ananke group. 3I/Atlas will pass close to this region, specifically on March 17, 2026, just one day after crossing Jupiter's Hill sphere. The object makes its closest approach to the Upori orbital zone. There's a theoretical scenario, improbable but physically possible, where 3I/Atlas could interact with this region meaningfully. If the object were to eject fragments during passage, or if it were to separate into multiple bodies, the dynamics become interesting. We're discussing what scientists call a Hill radius event, an interaction occurring precisely at the gravitational boundary where Jupiter's influence takes over. If 3I/Atlas remains a single coherent body, it passes through and continues outward. But if it's something more complex, if it's carrying something that could be released, then this boundary represents a perfect delivery zone.
The timing keeps researchers awake. The alignment essentially established this trajectory. If the sunward jet is actually propulsive maneuvering, it may have served as course correction calculated to ensure this specific Jupiter encounter. Imagine skipping a stone across a pond. The stone is 3I/Atlas. Jupiter represents the far shore. The stone moves at 66 kilometers per second. If a fragment separates from that stone at precisely the right moment with precisely the right velocity change, it doesn't cross the pond. It stops. It begins orbiting. But here's where physics presents a fundamental obstacle. To convert a 66 kilometer per second flyby into a capture orbit requires an enormous velocity change. Scientists call this delta V, and the delta V required here is massive. Jupiter's gravity is immense. Escape velocity near the cloud tops is approximately 60 kilometers per second, but 3I/Atlas isn't skimming cloud tops. It's passing 53 million kilometers out. At that distance, Jupiter's gravitational grip is much weaker. The escape velocity at encounter distance is only about 2.2 kilometers per second. This is the speed limit for becoming a moon. If you're moving faster than 2.2 kilometers per second relative to Jupiter at that distance, you're not captured. You're a visitor passing through. 3I/Atlas is moving at 66 kilometers per second. Subtract 2.2 from 66. The object is traveling approximately 64 kilometers per second too fast to be captured by gravity alone. For any part of 3I/Atlas to remain in the Jovian system, it would need to shed that 64 kilometers per second of excess velocity essentially instantaneously. This contradicts everything we understand about natural fragmentation. When comets break apart naturally, whether from rotational stress or thermal cracking, pieces drift away gently. The forces involved are modest. Fragments might separate at 5 meters per second, perhaps 10. In the most violent outbursts ever recorded, events where subsurface volatiles explosively vaporize, fragments might receive a kick of 1 or 2 kilometers per second. Those are extreme cases, documented only a handful of times in cometary observation history. We need a velocity change of more than 60 kilometers per second. The gap between what nature provides and what physics requires isn't a small discrepancy, it's an unbridgeable chasm. There's no known natural mechanism for a small icy body to explode with enough force to halt a fragment against a 66 kilometer per second approach without vaporizing that fragment completely in the process. The energy required would destroy what it's trying to slow. The energy requirements are genuinely staggering when calculated properly. Kinetic energy scales with the square of velocity. This isn't linear. Doubling velocity quadruples energy. To decelerate a fragment by 60 kilometers per second requires energy release comparable to a focused nuclear detonation. Not a chemical explosion, not volatiles vaporizing. Nuclear scale energy, precisely directed. Physics simply doesn't allow this through any natural process we've documented or theorized.
So what does this actually mean? It means if we detect a new moon appearing in Jupiter's system after March 17th, we're not looking at a natural phenomenon. Nature doesn't have braking thrusters. Nature doesn't perform orbital insertion burns. If an object separates from 3I Atlas and enters stable orbit around Jupiter, that object executed a high-energy maneuver. A precisely directed velocity change, an impulse that canceled approach speed and dropped the fragment into gravitationally bound trajectory. Remember the anti-tail? That sunward jet proved the object has a mechanism for directed outflow. It proved the object can maintain stable orientation. If that same mechanism is capable of high-thrust events, or if the jet we observed was actually a braking burn performed early to fine-tune arrival, the picture becomes coherent. This connects to theoretical concepts existing in scientific literature for decades: the Bracewell probe, the von Neumann probe, hypothetical autonomous spacecraft designed to travel between star systems and monitor what they find. A probe performing a planetary system flyby might deploy a subprobe. To deploy that subprobe at high relative velocity requires high impulse separation. The seemingly impossible velocity change required to leave something at Jupiter is precisely what such deployment would require. If 3I Atlas departs our solar system intact, but Jupiter gains a new satellite, celestial mechanics tells us that satellite didn't arrive by accident. It would have to be placed there deliberately, with precision. The statistical improbability of alignment, combined with the physical impossibility of natural capture, creates a logical corner the natural object hypothesis cannot escape. We're forced to consider alternatives. The appearance of a new Jovian moon after this encounter would be extremely difficult to reconcile with purely natural origins. It would represent a technological signature. Let me be precise about that term. Technological signature doesn't mean a photograph of spacecraft. It doesn't mean a radio message. It means data that cannot be generated by normal background processes of the universe, data implying engineering. The 400,000 kilometer jet pointing upstream against solar wind, that's a potential signature. The 1 in 10,000 geometric alignment, that's a potential signature.
A captured moon appearing at Jupiter in March, that would be the signature. What happens next? March 2026 offers a rare and potentially decisive observational opportunity. This isn't speculation or distant planning. We have instruments in position. The encounter will be monitored by ground-based telescopes worldwide and by NASA's Juno spacecraft currently orbiting Jupiter. Juno is the critical asset. The spacecraft has orbited Jupiter since 2016. Its instruments have weathered nearly a decade of intense radiation exposure but remain functional. NASA has already adjusted Juno's observation schedule to account for this event. The spacecraft won't be close enough to image surface details. The distances are too vast. But Juno is perfectly positioned to detect aftermath of any significant event. If 3I Atlas releases energy, if it fires any kind of thruster to decelerate a payload, Juno's wave instruments and magnetometers might detect resulting plasma disturbance. Jupiter's magnetosphere is sensitive to perturbations. An energetic event at the Hill sphere boundary would likely produce detectable signatures. If a new object enters Jupiter's system, Juno's camera can search for it in weeks following encounter. We will be watching. This contradicts assumptions about our preparedness for such events. Usually, interstellar objects pass too quickly for comprehensive study. This time, we're waiting at the finish line with instruments ready. Here's the crucial point. If nothing unusual happens, if 3I Atlas flies past Jupiter, remains intact, and continues outward without leaving trace, we'll be left with a profound mystery. But it will be a mystery still categorizable as natural. We'll rewrite textbooks about cometary jets and geometric alignments possible through random chance. 3I Atlas will be classified as an exotic comet, strange but natural. But if something stays behind, if Jupiter gains a new satellite that wasn't there before this encounter, then humanity faces a different situation entirely. We would transition from a species speculating about life elsewhere to a species studying an artifact deposited on our cosmic doorstep. The impossible velocity change would become proof of engineering. The technological signature would be confirmed. We are weeks away from what may be one of the most significant moments in astronomical history. Whether 3I Atlas proves an extraordinary freak of nature or a messenger from another star system, it has already secured its place in the scientific record. No object has ever presented this combination of anomalies. No previous visitor has challenged our models so thoroughly. The evidence has accumulated across every aspect we've examined. The physics-defying jet, the statistically improbable alignment, the precision trajectory toward Jupiter, the capture physics problem eliminating natural explanations for any material remaining behind. Each piece individually could perhaps be explained with sufficient creativity, but together they form a pattern demanding serious consideration of possibilities we've previously dismissed as speculation. The scientific method requires following evidence wherever it leads. It requires updating hypotheses when data contradicts assumptions. 3I Atlas is providing data contradicting many assumptions. Whatever conclusions emerge from the March encounter, the process of reaching them will advance our understanding significantly. If natural explanations prevail, we'll have learned something profound about the diversity of objects drifting between stars. We'll have to expand models to accommodate behaviors we thought impossible. Cometary science will be rewritten. If technological explanations become necessary, we'll have learned something even more profound about our place in the universe and what else might be moving through darkness between stars. The questions raised by 3I Atlas deserve answers, real answers, based on data, not speculation, not dismissal, not sensationalism. Rigorous scientific analysis of extraordinary observations. The coming weeks will bring more data, more observations, potentially more anomalies to analyze. This object has raised questions deserving careful attention. Not sensational speculation designed to generate excitement. Not dismissive skepticism refusing to engage with anomalous data. Careful, rigorous attention to what evidence actually shows and what conclusions that evidence supports. Until March, keep watching the data. Keep questioning assumptions. Keep demanding evidence for claims. And keep looking up, because something is approaching Jupiter. Something that has already defied our expectations repeatedly. And whether it proves natural or otherwise, understanding what it is will require all of us paying very close attention to what unfolds in the next few weeks. The universe is about to answer a question we've been asking for millennia. We just need to be ready to hear it.